Greetings to you, ladies and gentlemen. Welcome back to Shexa's YouTube channel. If you truly like the content that I am uploading on this YouTube channel, please give me thumbs up. That is, give me your likes. And if you think that there's something that needs to be corrected or added, please drop your suggestions and comments in the comment section. And if you feel that this content is relevant for someone else, please do share, and most importantly, subscribe so that you do not miss out any new video that I upload on this YouTube channel. Today we're going to look at SQL database keys and SQL data insertion, SQL data updates. So what we are mainly concerned about is database recordings. That is, we want to work with database table records or database records or data records. In other words, we will be dealing with the tuples or rows or records. So these three terms are the terms that are used to refer to the same thing: tuple, row, and record. Usually they are used as to refer this to the same thing. So let's start with keys. Let's start with database keys. Somebody may ask, what is it that you call a database key? A database key. So as the name itself is saying, a database key, keys, as their name suggests, it is a key part of a relational database. It's a key part, it's an important part, it's a critical part of a relational database, and it is a vital part of the structure of a table. So there are two things: the table itself and the database as a whole. So a key plays a role for a table or a relation or for entity, and then it also play a critical role for the relational database. So in other words, we are just saying a database key is a critical part of a relational database and is a vital part of the structure of a table. So that's the definition of what a database key is. So like I said, keys are, as their name suggests, a key party or a critical party of a relational database and a vital part of the structure of a database table. So these keys, they ensure that each record within a table can be uniquely identified by one or a combination of fields or columns within the table. So they help enforce integrity. For instance, we have entity integrity, referential integrity, and so forth. And they also help they help in identifying the relationship between the tables. That is, we will be trying to get how this relation is linked to the other relation. So the keys, they play all those roles. So there are certain types of database keys. We have these types. There are three main types of keys, and these are candidate keys. We have primary keys and foreign keys, and there's also an alternative key or an alternate key. Some they call it a secondary key, and as its name suggests as well, it's an alternate or it's a secondary, meaning to say it's a key that can also be used as primary key. So it's a secondary key or an alternate primary key, a secondary primary key. So we have a primary key, and as well we can have an alternate primary key or a secondary primary key. So a secondary primary key and an alternate primary key is the same. but you won't find it written secondary primary key, but you find it written secondary key. You won't find it written alternative key, alternative primary key, but you find it written alternate key. So you need to be very careful with these terms. So these are the three main types of database keys that we have. We have candidate keys, we have primary keys, and foreign keys. So mainly all database keys, they fall under these three key types. They fall under these three key types. Let's now look at a super key. What is it that we call a super key? So a super key is any subset of attributes of a table. It's any subset of attributes of a table. So it's any subset. So it's any group of columns that exist in a certain database table. But this group, they can uniquely identify all the tuples of that table. They identify all the tuples of that table. So I'm just saying, if we have since all the tuples in a relational database table, since they are unique, it means all the columns of that table, all the columns, a combination of all the columns gives us a super key. And then all subsets of that main set, that is other columns or other columns of the table, which can uniquely identify each record or each tuple or each instance of an entity, we can call that a super key. So it's different from the primary key and candidate keys in that only the minimal super keys are the candidate or primary keys. What do we mean by that? We are saying the super key is different from the primary key and candidate keys in that the only in that the primary keys or candidate keys, they consist of minimal super keys. So by that I mean a super key, we cannot say a super key is a primary key or is a candidate key. You will see when when I will elaborate more. A super key is any subset of any subset or any set of columns that can uniquely identify a record or a tuple or an instance of an entity. And a primary key or a candidate key is the minimal or is the subset with the minimum number of columns for that table. So a primary key is the minimal super key. Is a minimal super key. By minimal super key, we mean a super key is a subset or is any subset of attributes of a table that uniquely identify a table, a record. So the minimum number of columns or the minimum subset, that is, if we have, let me give you an example. Say we have 4 columns, and then if we combine all the 4 columns, we can uniquely identify a record. If we combine three of the columns, we can uniquely identify a record. And if we combine 2 columns, it means we can identify we can uniquely identify a record. But if we have only 1 column, we cannot identify a record. So it means the minimum number of columns is 2, and these 2 columns, that's what we are calling it's a super key as well, since it's a subset of attributes of a table which uniquely identify a record or records in a database table. But this is now what we are calling a candidate key or a primary key. You will see when we start to talk about primary keys and candidate keys. So by this we mean we can perform Let me give you the definition. So this is we can call a super key any combination of fields within a table that uniquely identifies each record within that table. So we can form primary or candidate key from a super key when we remove all the attributes that are not necessary for its uniqueness. So since we said all the columns, if you combine all the columns for any table which is in a relational database, all the columns or that set is a super key, and then we can remove some of the columns that are not necessary for unique identification of each record. By doing that, we will be forming a primary key or a candidate key. So in essence, all primary or candidate keys are super keys, but not all super keys are primary or candidate keys. So by the formal definition of a table, we know that the tuples of a relation are all unique. Like I said, in any relational database, relational database table, all the records or all the tuples are unique. So the set of all attributes itself is a super key, like I said earlier. So a candidate key is a super key, but a super key is not a candidate key. A super key is not a candidate key. I mean, a super key is not always a candidate key. So that's a super key for you. That's a super key for you. And then let's look at super key examples. I need to use the tables that we created in our previous lectures. So if you haven't watched our previous lectures, please make sure that you click on this link that is appearing at the top right corner of this content, so that you can go back and watch part 1 and part 2 of what we are doing right now. So this table is struct table. I'm sure everybody is having this table in their MySQL database. So that's what we are having, structs, and our super key is regnum make model. The first default super key is a combination of all table columns. So regnum combined with make combined with model combined with service and mileage is our super key, is our first super key. And then here are the examples. We can uniquely identify all the tuples using regnum and make. We can also identify all tuples using regnum and model. We can identify all the tuples using regnum and service. We can also identify with all the table columns, like I said earlier. We have regnum, model, make, mileage, and service. So here I'm just saying we have a column which is being combined with other columns to make subsets of the whole set of the mother set that we are having, which is all the columns of this table. So if we combine this column with a unique attribute and combine it with any other column, we can form a super key. So that's what we are having here. So these are the examples of what we can call a super key. So if you are asked, can you give me an example of a super key? The first one is to list all the columns of a table, and then you say here we have a super key, and then we can have any subsets that we can formulate. So here I just gave you 4, but you can have more. Maybe you can say regnum, model, and mileage, regnum, model, and service, regnum, and all those, making all those combinations to come up with super keys. Right. So let's now talk about what a candidate key is. What is a candidate key? So a candidate key, a candidate from this, I want to give you a literal example. Let's say we are attending a job interview and we are 7, all of us, and let's just say there's only one person needed for the job and we are 7 attending or invited for the interview. Only one will win the job, but all the 7 of us, we are all candidates. What does that mean? All the candidates, all of us, each one of us can get the job. Each one of us is can get the job. So it means they have perused our CVs and observed that all of us, all the 7 of us, each of the 7 is suitable for the job, but they now want to get the best, that is the main relevant one for the job, the main or the most suitable one for the job. So that's what we are saying here, all the candidate keys. So a candidate key by definition is a subset of a super key. Let me just give you this first before I give you the definition. So a candidate is a subset of a super key because we have removed unnecessary attributes, attributes that are not necessary for unique identification of records in a database table. So a candidate key is a single field, or the list, get this correct, is a candidate key is a single field or the least combination of fields that uniquely identifies each record in a table. So that's what a candidate key. A candidate key is a single field or the minimum combination or the least combination of fields that uniquely identifies each record in a table. Right. So let's talk about the relationship between a candidate key and a super key. A candidate key is a super key with no repeated attributes. A candidate key is a super key with no repeated attributes, and those attributes that are removed are the ones that we have said they are not necessary for unique identification of database table records or attribute or tuples. So a table can have multiple candidate keys, but only a single primary key can be selected. So like I said, only one person is needed for the job, but we have 7 candidates. So from the 7, we can choose one. So meaning to say we can have only one person for the job, and we can have several candidates for that same job. So the properties of here's the definition of the formal definition of what a candidate key is. So a candidate key is any minimal set of attributes which can uniquely identify a tuple or record within that table or relation. So here are the properties of a candidate key. It must contain unique values, no repeated values for this column that we are calling candidate key. So a candidate key may have multiple attributes, must not contain null values. It should contain minimum fields to ensure uniqueness. It must uniquely identify each record in a table. So that's a primary key for us theoretically. Now let's look at examples, candidate key examples. Here we have our table code drivers, and I'm sure that everybody is having this query or this SQL command. Right, we are saying we have our primary key here, which is ID num, and then we have phone. So phone is unique, is having unique, and then ID num is selected as primary key, and primary key by definition is or by default, any primary key column by default is having unique values. So our candidate keys, that the candidate keys that we have from this query includes ID num and phone. So we can say phone can be our primary key, ID num can be our primary key, but we have selected ID num from this list because it's the one that suits most for driver identification, because we need to know the ID number of the driver. That's how we selected the primary key. But let's now see the table that you have right now. If you have been following our video tutorials, it means you have email address updated as well, so you will see as we go. So this is our first candidate. If you assume that we haven't selected it as ID now, and then we have another candidate which is phone, because it's unique. But now we have another candidate which is email address. No two drivers can share the same email address, but from our definition here we didn't define it as unique. So two drivers, from this definition, two drivers or more can share the same email address. But we have thought about it when we were creating our database, and we have ensured that email address columns values must be unique. So that's why we came up with, so you see here we are having a broken line to show that email address is not defined as unique, so it's not a candidate key, but it can possibly be a candidate key if we do what? If we alter the table and modify email address and add unique constraint to it. That's when it qualifies to be a candidate key. If you remember, we have executed this command earlier in our second video tutorial. So that's a candidate key for us. Let's now look at another key which I think everybody is aware of or is fully understanding it. We have a primary key. So a primary key is, I think this one is well known. Let me just give you the definition here. So a primary key is a candidate key that is most appropriate to be the main reference key for the table. So as its name suggests, it is the primary key of reference. It's the key of reference for the table or for the relation to point out or uniquely identify instances of an entity. So entity integrity is enforced, and the key is also used throughout the database to help establish relationships or links with other tables. As with any candidate key, the primary key must contain unique values, must never be null, and uniquely identify each record in the database table. So there can be more than one candidate key, like I said earlier, in a relation, out of which one can be chosen as the primary key. We can have 7 candidates for the job, but only one can be selected for the job. So that's the candidate key for us. And let's just look at that's the primary key, sorry, that's the primary key for us. Let's look at primary key examples. Right, we have drivers here, and our primary key is ID num, selected from the list of candidate keys. So that's our primary key, and our other keys, they are not selected. So those that fail the interview, they will not get the job, so we cancel them like that. Even if they are unique, even if they do not repeat values in their columns, they are not primary keys. You only select one as primary key. Let's now look at foreign key. So what can you say is a foreign key? A foreign key is generally a primary key from one table that appears as a field in another table. Where the first table, in the first table, I normally call the first table as the primary, as the parent table or parent relation, and the other table where the primary key is appearing as the secondary or child table. So the primary key of another table that is appearing on the other table is what we are calling the foreign key. So here is the formal definition. A foreign key is a primary key from one table that appears as a field in another table where the first table has a relationship to the second. But now let's talk about it in this way, but I think I've talked about it earlier in our previous video tutorial. So if you want more about that, you can get to the videos, and the links to the videos are provided in the description. So let's look at what examples. So here we have what we have, if you remember from our previous lecture, we have this kind of relationships between our tables. Let's just get to this point. This is our previous slide where we are having these relationships. We have our tables like that, and they are connected like that. So here we are having regnum is primary key in trucks table, and then regnum in truck driver is which is existing in trucks table as primary key. Now it's a foreign key. Same applies. idnum is a primary key in drivers, and then it's a foreign key in truck driver. Same applies to ttid, which is a primary key in truck driver and foreign key in trips. So which of these are the foreign keys? I think everybody knows this because we've talked about it in our first video tutorial in this series. So these are the foreign keys: idnum, regnum, and ttid. So clear examples. So foreign key constraint identifies the relationships between the database tables. This is our previous lecture as well, emphasizing on foreign key. I don't think we need to take much time on this. We don't need to have much time on this. It's in a parent table, that's our primary key, and in the child table we have our foreign key. Right, so that's the relationship that we have. We have our primary key, we have our foreign key, is illustrated here. It's illustrated there. So that's the foreign key for us. Let's now look at secondary or alternate key. So like I said earlier, I think I've defined this. A table may have one or more choices for the primary key. Collectively, these are known as candidate keys, as we discussed earlier. One is selected as the primary key. Those that are not selected are known as secondary keys or alternate keys or alternative keys. So this is the alternate key definition. So like I said earlier, we have 7 candidates for the job, but only one can pass and get the job. So if somebody passed the interview and is selected for the job, we say that is the primary key. But maybe gets another job somewhere else, we can take the next best. So all those that have been interviewed are the candidates. So we can say we have we've tried to get the first one and we didn't get him. We lost him to another organization which is paying more. We do the same for the second, we do the same for the third, fourth, fifth, and sixth. It means the seventh one can still get the job if he performed, or if he or she performed well to get the job, since he or she is the candidate. So that's the alternate key for us. So here are the examples of alternate keys. So if I may ask, you can list these examples, because I think the definition was clear. So the primary key cannot be selected as an alternate key because it's already a primary key. That's a selected primary key. That's why you're having a broken line underlining it, and a red cross over ID num as candidate as an alternate key. So it's not an alternate key, but phone, yes, it's an alternate key or a secondary key, because we can use it as primary key in place of all other primary key, in place of ID num. We can also use ID num for as long as we define it as unique. So that's alternate key for us. And then we have simple key. We have simple key, we have composite key, we have compound key. So these three, they are different. Let's start with a simple key. So a simple key is any of the keys described before. That is primary, secondary, or foreign key that may comprise one or more fields. That may comprise of one or more fields. So a simple key, I mean, among all the keys that we have defined earlier, that is the primary, secondary, and foreign, they may comprise of one or more columns. But a simple key consists of a single field to uniquely identify a record in its parent relation, that is the table. So a simple key is a primary key which uses only one column or one field or one attribute to uniquely identify a record or a tuple. In addition, the field in itself cannot be broken down into other fields. For instance, we have ID num that we have talked about, which uniquely identifies a particular driver and is a single field, and therefore that's a simple key. No two drivers would have the same ID num. So that's it for simple key. So here are simple key examples. We have ID number, definitely is our example. And then let's now talk about the compound key. Compound key. Let's not let me do it this way. Right, we now want to talk about compound key. So we said a simple key is a primary key which uses only one field, and now we have a compound key. So a compound key is a primary key consisting of more than one simple keys, but there's something that you need to note. I said a compound key consists of more than one field to uniquely identify a record. A compound key is distinguished from a composite key. We will talk about a composite key later. A compound key is different from a composite key in that each field which makes up the primary key is also a simple key on its own. So we are saying a compound key is a primary key which consists of more than one field, but each of the fields that are making the compound key, they are simple keys, or we can use them as primary keys. That is, each of these columns can be a simple key. So that's what a compound key is. So from our table definition earlier, we didn't define any compound key. That's why we're having the query that we are about to run. So let's open our workbench. Let's open our workbench. Let's open our workbench. Here is our workbench. So what you are supposed to do is, I'm sure some of you might not have the previous queries that we have executed. So what you can do is you can download the links, the SQL query for video tutorial 1 and the other query for video tutorial number 2 from the links provided in the description. So what you will do is you will need to, or if you have followed but you have distracted or destroyed some of the properties, you may download the SQL queries from the links provided in the description, and you can run them. So I will open the SQL query. So my download folder is this one. Let me just show, go back. Right, so the ones that you are supposed to run are these ones. This is for video tutorial number 1. So you run this SQL query, these SQL queries. So you execute it, it will delete and then create the new database with the structure that we are expecting you to have. So you execute and it's running here. So it will delete this database. It has been deleted, and you will see that it's executing successfully and giving us some warnings where we need to be warned. It's still running. So if you download the first query, you download it and execute it. Right, it's done executing on my side. So I can refresh and check. I now have the table and the database and its tables, but we do not have users table. So you will need to execute the second query. That is, the link to that query is also in the description, and the query name is this one, track management DB creation query 2. You open that, then you execute it. This is what we have done. This is what we did on video tutorial 2. This is what we did on video tutorial 2. You can execute it and it is supposed to run successfully. So once it's done running, it's running here. Right, it's done running, but it's having a what can I call it, a warning. Yes, it's a warning. It's having a warning here. So this warning is all about what we did here on email. So we have modified email address to unique, but we've done this earlier in this query here. That's why it's telling us it's duplicate whatever. So that's it. So let's now run Let's now run the query to create. Let's run the query to modify something so that we can have let's modify one of our so you can create new SQL table or new query table. So we want to alter tracks table. So let's open tracks table and see what we have. Let's refresh. So we now have users. Let's refresh here. Let's click on tracks so that you see it below here, left bottom side. So what we now want to do is we want to alter the tracks table. This is the tracks table, so that we have, so you can see that we have primary key, regnum is the primary key, only regnum is the primary key, but we want to add another column that can be used, or that can be used as a primary key on its own. That is, we want to add a simple key, a simple alternate key. So you get the combination of terms that I'm using right now. So we want to create a simple primary key, a simple alternate key. So what we will do is we alter first is use database, and what's the name of the database? Use track management DB. So that's the database that we want to use. And then what we want to use it for, we want to alter the table that is called tracks. And then these tracks, what do we want to do? We want to add a column. So we want to add a column for these are tracks. So we can say track, let me just call it track vehicle identification number, that's VIN. So I can add a comment here to say VIN stands for vehicle identification number. Right, so that's just a comment, and I can put it below there. So VIN, and VIN is of this type varchar. You now know what varchar stands for, and then it's unique and not null. So that's the column that we have added. And then what do we want to do now? So let me put this comment above. Right, so what do you want to do with this? We want to drop or remove the previous primary key. So we can drop what? Drop primary key. And then after dropping a primary key, we now want to add what we are calling the compound key. So we say add primary key. So in this context, add and drop are acting as opposite terms. And then our primary key now is a compound key, which is a combination of simple keys. So vehicle identification number can be used as a primary key. So this is what we are calling as compound key. So that's the compound key. So let's execute and observe what will happen. So check here our table. Regnum is our primary key, and then we have executed the alter table SQL command. Then let's refresh and check. You can see that we have regnum underlined, VIN underlined, and it's having PK, which stands for primary key. So we now have a compound key which is having regnum and VIN, vehicle identification number. So we are done with compound key. So that's the query that we have. That's the query that we have here. That's the query that we have here. So a compound key examples. So that's the query that we have executed in read num and vin. That's the compound key that we have. This is what you have defined. So let's now talk about composite key. So a composite key consists of more than one field to uniquely identify a record. But the keys, the columns that are used to define the primary key, they are not simple keys, or they cannot by themselves uniquely identify a record or a tuple. So here is, so by this we mean a composite key differs from a compound key in that one or more of the attributes which make up the key are not simple keys in their own right. So at least one of the keys that formulate composite key cannot uniquely identify table tuples or table records. So composite key examples. So let's look at examples here. So what we're going to do is, since this one is executed, we've executed this, let's comment it out so that we do not run it twice. Let's now let's work with table. Right, let's work with users table to create a composite key. So what we do is we alter table, and the table that we want to alter is users. You can see that in users we have fname is unique, if not mistaken. Yes, fname is unique, since it's bolded there, that's what I'm assuming. Right, so we have alter table users. Then what do we want to do with users? We want to add, it doesn't have any primary key, we do not have any pk here. Add primary key, and the primary key is having fname combined with lname and username. So that's our primary key. So here we now have what our composite key. So that's the composite key for us. Let's execute it and observe what will happen. Look here, it will change. We are running. Yes, executed successfully. Let's refresh. You can see that we have three columns that are defining our composite key. So these are the three columns used to define our composite key. All right, these are the three attributes that we have used to define our composite key. So that's it for today. Thank you very much for being with me here. May God bless you, and please truly like, if you like the content that I've given you, and give me some comments, subscribe and share. Enjoy the rest of your day. Goodbye.